Okay, so we're still working. This is the second half of the video for graphing the expression r of x equals x squared minus x minus 12 all over x minus 5. So at the end of the last video, we were talking about the vertical asymptotes. Okay, now we said there was a vertical asymptote at x equals 5. I went ahead, filled in my chart for the values as x approaches 5 from the left. As you can see, as x approaches 5 from the left, the y values are heading more and more negative. So this tells me that as x is approaching 5 from the left, y is heading towards a negative infinity. Similarly, over here, I went in, filled in the chart for as x approaches 5 from the right, so it's getting closer and closer to 5. And then I look at the y values. I have 49, 89, 809. It's clear to see that as I approach 5 from the right, y is heading towards a positive infinity. Okay? Now, part E, or question E on the exam, will be to find the horizontal or oblique asymptote, if one exists. Okay? Now, to find horizontal or oblique asymptotes, you want to go ahead, you want to reference page 194 in your textbook, okay? We have this wonderful theorem, okay? Now, this wonderful theorem says to compare the degrees of the numerator and the degrees of the denominator. So looking at our expression, the degree of the numerator is the degree of the highest powered exponent, which is a 2. The degree of the denominator is the highest powered exponent. That is a 1. So 2 is 1 more than the degree of the denominator. So 1 more than 1. So if the degree of the numerator, if the degree of the denominator is equal to, is 1 less than the degree of the numerator, okay, we have an oblique asymptote. That is where this is coming from. So to find the oblique asymptote, okay, now remember, we said this in class yesterday, or earlier in the week. A graph cannot have both a horizontal and an oblique asymptote. It has to have one or the other. It cannot have both. There's also a possibility it would have none. And that is when the degree of the numerator is 2 or more greater than the degree of the denominator. So now we know we will not have a horizontal asymptote, only in an oblique asymptote. So to find the oblique asymptote, you can either use long division or, I hope I spell this right, synthetic division. Okay? Either one will work. Now, if what you're dividing is of the first degree, you can use synthetic division. If it's a 2 or higher, you have to use long division. So this one's pretty nice. I'm going to go ahead and use synthetic division. Okay? So in using my synthetic division, I'm going to be taking 5 into the coefficients of my numerator. So that'll be 1, -1, and -12. Doing the synthetic division then, this will be 1, 5, 4, 28. Now mind you, this is my remainder, okay? So doing the long division, this gives me the equation y equals x plus 4 plus 8 over my divisor of x minus 5. Now, the oblique asymptote is simply everything but the remainder. So my oblique asymptote is y equals x plus 4. Now, question F, okay? I'm going to show you exactly what it says here on the exam, okay? This is how it's stated in the exam. I took this directly from the text. Use the zeros of the numerator and denominator to divide the x-axis into intervals. Determine where the graph of r is above or below the x-axis by choosing a number in each interval and evaluating r there. This is essentially what I'm saying is construct the number line for me. Okay, construct the number line. Now, when we construct the number line, oh, this is going to be bad trying to draw. Oh, wow, that's terrible. Okay, anyway, here's our number line. Remember, on this number line, we put our x-intercepts. So, from part 3, we found our x-intercepts to be x is 4 and x is equal to negative 3. So here's negative 3 on the graph. Here's also 4. So we put our x-intercepts. We also put any points in which we tossed out in the domain. This one was fairly nice. We only tossed out the point where x was equal to 5. Okay, so that's also going to go on the number line. Now we're going to go ahead. We're going to pick a representative element from each of these intervals that we've broken the number line up into. All right, this will determine if the graph is above or below the x-axis. So I'm going to go ahead here. I'm going to pick some numbers that I like. I'm going to go ahead. I'm going to pick x is equal to negative 4. I'm going to go ahead, pick x is equal to 0. I'm going to go ahead. I'm going to pick x is equal to 4.5. And I'm going to go ahead and evaluate when x is equal to 6. I'm going to look at these at each case. So r of negative 4, r of 0, r of 4.5, r of 6. Okay? Again, we're putting these into the original expression. All right? In doing that, okay, I went ahead and did this already because save a little bit of time. This will be a negative 0.8 repeating. This will be 12/5. This will be a negative 7 1/2. And this one will also be 18. Since this value is negative, every value on the graph in this interval will be negative. Since this one's positive, every interval or every point on this graph here will be positive in this interval. Same thing here. This one will be negative. This one will be positive as well. Now the last step is to go ahead and graph this. Okay. May I make the suggestion? Go ahead, plot all the points that you know first. Now we first got points from our intercepts. I have a y-intercept of 0, 12/5. I have an x-intercept of 4 and negative 3. So I'm going to go ahead and plot those on the graph. So 0, 12/5 is right about there. 0, 4 is right there. Negative 3, 0 is also right there. Okay, so that's my y-intercepts and my x-intercepts. I also got a few additional points from my interval. I got negative 4 was equal to negative 0.8 repeating. I already plotted that one. 4.5, negative 7 1/2, 6 and 18. Let's go ahead, let's plot those 3 points on the graph. So here is negative 4. Go down a little bit. That'll go right there. All right, I have 4 1/2. 1, 2, 3, 4, 5, 6, 7, 7 1/2. That's going to be right about there. And then 6, 18. So 1, 2, 3, 4, 5, 6, all the way up to 18. That's right about there. Okay, so those are all the points I know on the graph. Now, let's go ahead. Let's plot our asymptotes. The first asymptote we found was our vertical asymptote. X is equal to 5. So here's 5. There's my vertical asymptote. Now, let's go ahead. We want to graph our oblique asymptote. Now, if you need to come up with a couple different points on here, remember, pick points that are nice. So 0, 4, 1, 5. Okay? Go ahead, plot those. Now remember, you're going to use a dotted line because, again, it is an oblique asymptote. It's not part of the graph. Oh, that's the wrong one. 3, 4. 1, 2, 3, 4. So, we're going to go ahead. Oh, this is going to be interesting. Oh, I really offshot that. All right, I'm gonna fix this.